Hello, this is CAD class of Khazar University, and in this class we will continue the design process we started at Mechanical Engineering Design class. So first step will be creating the parts. First part would be the bottom side of oil mixer we started at the design class. So this is the interface. There are the sketching tools and extrusion tools. So this software is about sketching what you need and then extruding or revolving to create bodies. So we will start from sketches, and since we have a circular geometry, we will choose the front plane for the sketching. So the bottom part would be an elliptical surface, which we have been taking from a standard. So we open the standard GHOST 65338, and we have a look at the 2.5 meter diameter geometry. So its dB should be 2.5 meters, and we have here the thickness of the plate, h1, hb. Hb is the height, h1 is also height of the straight side. So we go to 2.5 meters, and at 2.5 meters for S, the thickness of plate 10, we get the data. The height, the straight height must be 40 millimeters, the height must be 625 millimeters, and yeah, so it also has the volume of it. The weight of it will be 562 kilos, and that's all the data we need to draw this. So we start by drawing a line which you can get here. This is called center line. Then we draw a parabol, the ellipse. So we draw it like this, and this ellipse has this dimension 625 millimeters, and this dimension has to be 2500. Apart from it, we have another value, h1, which is 40. So we draw the h1, and so there's smart dimension. You press on the line, you get the dimension you need. And then there is trim entities. You press it and you trim the entities you don't need. 40 millimeters, it's good. Yeah, it's standard, it's good to use it, it's standard. However, in production you may face problems, and as I explained the last class, if you take 40 millimeters for this part, in production it becomes non-homogeneous. So at some part it will be 20 millimeters, at some part it will be 60 millimeters. So it's always good to make it, like, let's say, take it 60 and then cut 20 millimeters and then reduce it to the normal size. So since it's our first design, we will take it even 80, and then we will write in our documentation to reduce it to the required value. Now we did this, and we are sure that however, wait. However, we would be better to make it. I think it's better to make it 40. Yeah, we draw it as it's 40, but when we give it to production, they do it as it should be. So we will tell production to make it larger and then cut it. So it's production side issue. So we will just do the next. We will offset entities, offset by 10 millimeters in reverse direction. As you know, the data we have here is for internal dimensions. As you see, internal diameter, internal height. So we do reversed offset. We get the offsetted parameter. We close the ends of it, and then it's straightforward. We just do the revolved base. We revolve it, but not like that, but like this. That's it. So this is our bottom part of the oil mixer. And yes, now what else has to be considered here? Well, the point is producing it from a metal sheet, from one metal sheet, will be impossible. The point is, usually metal sheets are of this dimension. They are around 1.5 meter to 6 meter. It's standard. So 1,500, 6,000 millimeters. And our bottom, this bottom part is 2.5 meter in diameter, and it's impossible to. So the issue is 6 to 1.5, so we have to go to the standard about the bottom parts and look at how they weld it. So there are a variety of types, and for us the best option seems to be the third option. The third option at the top is best because it's the center. We need to have a outlet pipe at the center, and you cannot cut it from the center. You cannot weld it from the center. So you do this option, and yes, we will just make it this way. We will make it like we'll take this, and before we do it, I have some things to point out. First of all, the welding. We should welding. So this part in blue will be welded to a cylinder part, and for welding it we go to the welding standard, which is 526480, and we go to the welding which is related to hour, and it must be this. No, wait, it must be, yes, it's C11, yeah, C11 type, stykowe сварка. We go to C11 and we look at the dimensions, and this at the right side is 10 millimeter. The sheet we have on the left side is 5 millimeter sheet. So we need to bevel it like 20 millimeters up, and we do it right now. We make it like 20 millimeter bevel. So we press on this face, create, create it, and we will weld from outside. So yeah, outside. So inside will be like this. Okay, we just go create the line. It's 2510, and let me check again. So there must be, so 2510, and we also should leave some tolerance for the welder. 2509, 1 millimeter tolerance in diameter, and we create the outer diameter, and then we extrude it for 20 millimeters. However, that way it would reduce the height of it. So instead of extruding, we will do the opposite of it. We will uh, we will extrude, not extrude. So extrusion is better option in this case. We give it internal length of 2500, and we extrude it to 20 millimeters. 20 may be too much, since in standard says 8 to 20, so 15 will do. So this is the way it has to be beveled, and we also need this 45-degree, you call it chamfer. So we put a chamfer here, which is 5 or 3. Let's do 5 for 45 degrees. Well, it should be 5.5. That's the chamfer, and this part is ready to be finished, and we have to save it. We'll create a new folder. We'll call it oil mixer. No, oh, we'll call it lubricant blender. And we, since it's part 1, we'll call it let's say Khazar SPD mechanical engineering 0001. So it's SPD means part, ME means mechanical engineering, Khazar needs Khazar University. Yes, we save it, and yeah, now we should create the hole as well. So we go to top plane, sketch the hole we need, and since the customer asked for 65 millimeters as internal diameter, we'll take a pipe with 6 millimeters of wall thickness, so it will be 71 millimeter. But since we are going to fit this pipe into this hole and weld it, we add additional 4 millimeters for the welder and dig a hole, extrude a hole. So in both directions for ease, That's the outlet hole of the oil lubricant blender. And the point is we have to weld it like from two sides. So let's look at the standard again. So L1 is given here. We read about L1 and we get data about L1. So L1 has to be not less than 20% of the internal diameter. Yeah, that's the L1 dimension. So here L1, yeah. So we will do it like this. We will create a square like this. And since L1 has to be not less than 20%, let's say 800 millimeters. It's not less than 20%. It's quite good enough. And we put a dimension 400. Yes, and we extrude it. We extrude it for us, and we get two bodies. They are symmetric. One body is enough for us, so we delete the other body, and you can do it this way, delete body, and that's the part one. So this is the part one. And the other thing is that before even bending it to this shape, we have to connect all the three parts, so we need to weld them to each other. But this thing I think I will show in the, maybe not, maybe I should show it here as well. So for welding the three parts, you need double-sided welding. So we go to welding standard. We look for double-sided welding procedure. So why double-sided, huh? Why is that the case in this geometry? It's because the operation they perform, the bending of the bottom, it's very advanced operation. If you do one-sided welding, it may damage your system and it will create issues during the welding testing. So you have to do double-sided welding, and for double-sided welding, I would suggest C25. So C25, the angle is 25 degrees. So we create a chamfer with 25-degree angle. So 25, we check it. So it's like in the middle, it should leave 1 millimeter. It leaves 2.5 millimeters to each side. 2.5. That's it. So that's the chamfer, the bottom chamfer. We also create the top chamfer as well, and I think that's it. So we created chamfers, the bottom and top chamfer for welding, and yeah, that's pretty much. Now we save it, and we save as. We save it as part number 2. We just go to the extrude part. We delete just the sides, and this is what we need. We delete the body, keep delete, we go to chamfer, check it, it's alright. Both of chamfers are alright. We do the same chamfer operation for the other side, but with flip direction. That's pretty much it's done. This part is also finished. We save it. Now we should create a new part. It will be the middle side of it. We will do it by sheet metal. We won't use extruding, we will do sheet metal. It will ease our job. And as you know, it has to be 2000 millimeters in height. So for 2000 millimeters, and we know that the diameter of the cylinder will be 2000 multiplied by P. Wait, no, 2.5 meter multiplied by P. It will be the length. So the length is 7.8 meters. So you will take a sheet material, 6000 millimeter length, two of them, two sheet materials, and weld them to each other. And at the top part you will do the same thing. So it will look like this. I'll just do it now. So front plane, top plane. I'll do it in top plane. So it will be 2500, and we have to put a cut place on it, because when you bend it, you bend a sheet, and when you bend a sheet, there will be a part which will stay not not connected. So that part we will weld, so it will undergo welding, and by standard it's around 3 millimeters. We trim this part. We make these two lines as helping lines for construction, and apart from it, I think that's enough. Now we go to sheet metal base flange tab, and we 1490 millimeters up, 10 millimeters. Is it outward or inward? Yeah, it's outward, as you see, 10 millimeters, but our thickness is 5 millimeters. However, uh, if we use 5 millimeter for outward, we need at least 2510 at inside diameter. So we do this and we get such a shape, and this is the middle part of the lubricant mixer in blender. And what's the use of sheet metal? So sheet metal has a flatten option or unfold option. Let's try unfold. With flatten. This flatten option makes the sheet open. Yeah, so this is the sheet which has been cut on the plasma machine, and then you put it on the bending machine and you bend it to this geometry. And so I'm gonna show the processes it undergoes. So when it's flattened in this stage, it goes the plasma cutting. So this is the plasma cutting part, which is done for this sheet plate. After plasma cutting, we go to sheet metal bending. Hmm, rolling bending. Yes. So these are the sheet plates. So after cutting this sheet metal, we need it to be cylindrical as this, and in order to get that geometry, let's say it's plasma again, it cuts the sheet metal. Let's keep it forward. So it goes into the bending machine and gets bended to desired diameter. It's operator control. This is three-roll machine. There are also four-roll machines as well. As they check the diameter with these molds they put. Then they put these metal parts and weld it. Finalization of the process, calibration. That's pretty much it. So this is the middle part of it, and we save it as part 3. So we save it as part 3, and we have also we have to make a bevel here, and bevel here, I guess it's, yeah, it's Let's look at the standard. It's one-sided bevel, so it's like this, C21, and 25 degrees actually is enough for it. Yeah, 25 degrees. We go to chamfer, we make it, we have to choose the edge, 25 degrees, and it should be around 4 millimeters, because 1 millimeter has to be here. That's pretty much, we save it as well. And do we need this? Yes, we need this chamfer as well, but we don't need chamfer here. So let me click it. No, let's leave it like this. It's okay. So we did it. We did part 3. Now let's do part 4. Part 4 is the top part of it. We just save it as part 4. We go to base flange and we reduce it to 500 and we save it as part 4. Let's make an assembly and see what we have achieved so far. We go to assembly, so we go to new assembly and we go to the assembly. We have to insert these parts. We don't choose a place, we just press the green button, it inserts at its origin place. We insert additional parts. Second, we insert the other parts as well. And the last part is the fourth part. And then we try to locate them. So if you press right click on this and press float, then you can move it. And here, as you see, these two parts are fixed. So we will use them as a reference. We will put this part on them by using mate function. So we mate it from this face. Try to pick the face, yeah. So it's the face to, let's say, this face. And we would like to make a distance between them, which would be around 15 millimeters in in this direction. Then we would like to mate this diameter to this diameter, and that's pretty much it. So as you see, we have mated it, it came to its position, and we can rotate it as we will. The most important part here is to make sure that the welding parts do not coincide with each other. My point is, if you put this welding part like this, so you have you have 1 2 3, like 3 welding seeing each other, it's not good. There must be at least 100 millimeter distance between these two welds. you cannot weld it like this. So it's highly suggested to rotate it 90 degrees, or at least keep at least 100 millimeters between the welds. Next step is to put this part at the top. So we go to mate, we click on this. Wait, we did it too fast. Let's cancel it. Again, we go to mate, we click on this part. Yeah, it's sometimes difficult to select, but yeah, I did it. I took the face at the bottom. I put it on this face, and then I just do the next, the radius to radius, at diameter to diameter. That's it. The only thing left is this part, and I just do linear component pattern, circular component pattern. I'm choosing this component to be patterned around this, and it will be 360 degrees. Wait, it will be 180. Yeah, 180 degrees. That's it. So as you see, we have officially finished some like 60% of the body. Now what we are left is to make the legs, and we need to make the top part and blades and some other small stuff. But the main body is ready, so we save it as Khazar. It will be gas part me. Gas means general assembly 001. So it will be our general assembly part. And in this class, I would like to stop 3D modeling here and do some draftsman work, which I will show you now. I will take this part, this cylinder, and make a draft of it for the shop floor, for the guys in the shop floor. So you go to the make drawing from this part, and you click on drawing. Then you can choose one of the standards. Like I usually use A31. So let's move to it. And yeah, this is it. So we have front, top, and variety of other parts. So we will take the top view, put it here, and apart from top view, we will also take flat pattern. Flat pattern is the thing that we got from sheet metal. This one will show the plasma guys what to cut and what to give for welding. And from top view, we will make a section view, something like this, and we will put it, I think it's better to make section view in this direction. I put it here. If you zoom in, it's something like this, and the scales are very big. So it's 1 to 50 scale, we make it 1 to 20, and this we put this here, we just write some information about it, something like this. So we insert a note. So we name it the open opened view. So metal sheet for plasma cutting, or let's call it prefabricated raw material. Yeah, that sounds more academic. We just move this one away, and we all know that this metal sheet it cannot be longer than 6 meters. So we measure it. It's 7.8 meters. Before we continue, I'll go to options and make some changes, like I'll change the font to Tahoma, change the dimensions. I don't want to see after point, the numbers after the point. We will use Sika line like 0.35 millimeter, and I think that's it. It makes these lines thicker and better visible. We just put a line here and we name it like this. So it will be 5990 millimeters. So this is where the welding will occur. So you will take two sheets, weld to each other like this, and for this line we will give format like thickness. I want to give thickness, but let's just leave it like this. It's okay. So we will just do the next. We will go to annotations, weld symbol. We will name it weld number 1, and the weld symbol will be like double-sided, so it's single butt and another, wait, it's this one and another single butt without root, yeah, since it's 5 millimeter sheet, it will be welded two. Two is the, it will be like something like this. So since it's 5 millimeter sheet, we will weld it from one side. So we go to weld symbol and name it number 1, and we choose single butt weld with like 3 millimeter CAD. We put it here. So this will be our first welding in this class. So we will weld it here, and after we weld it, we give it to the plasma cutting. After plasma cutting, to rolling. After rolling, we get this dimension, this circular pipe, a circular cylinder. And for cylinder, we should put the center line, which is put like this. Also, we need to put center mask like this. And after you put them, you also need to show the bevels you did. So this 2D sketch is the sketch which will be received by the production side, by the shop floor, and people will do operations depending on the sketch, and you have to show them the bevels you have drawn. So you just come here, go to view layout, take detail view, make one detail view, and you place it here. Also, you just make it bigger, like 1 to 1. It's still not clear, so you can use user defined 2 to 1. Yes, that's much more better. And here you do the next. You draw a half circle like this, and another half circle like this, and then you do the next. You give the dimensions. So this is 25 degrees angle, this is also 25 degrees. You need to give it. If you don't give it, the guys in shop floor will come to you with questions. How and what? What is what? How is it? How should I do it? It's not clear. I don't understand it. La la la. So it's better to give all the data to them and make sure they don't have questions. So 5 mm is the thickness, 4 mm is this barrel. So 2 barrels. Oh, this one jumped a little bit. We do it like this. Right. Okay. So where's the this detail C 2 to 1, and this is welding number 2. So we go to weld symbol, we put number 2 here. We don't write any numbers, we just show it to be welded like this. Yeah, we weld it like this. We don't put CAD, it's welded inside it. And what can be done is very simple. You can go to area hatch fill and make it solid and fill it. So with the boundary, this. But before doing this, we need to sketch lines. So we sketch these lines, and from the other side as well. After we do that, we go to area fill, solid boundary, this, 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 and this. That's it. So this black color means it has to be welded here, and obvious it's obvious for the welder what has to be done. This C is too small to see, so it's really very small to see. And what can be done? Well, you can just draw a line, draw some line to show that it's related to this one, but I think there is no need for that. So this is the one part, and I think that's all about welding. Now we have to put the missing dimensions. missing dimensions such as the inner diameter. So it's radius, but you can go to leaders and make it diameter anyway. And we need to put outer diameter. Also can be handled by leaders outer diameter. And apart from it, we need height of it. So height is here, and we need to put some information about these procedures, like technological background behind it. So first of all, you write please refer to what? Of course, the welding standard. Please refer to GHOST 526480. So you just write GHOST 54 52 64 80, and yeah, that's it. Refer to, and then you write the tolerances. Tolerance ether. So how to write tolerances? Tolerances in general drawing. You just have a look at it. So generally you can see the tolerances here. It's 24 0 to 0 minus 0.2. It's the tolerance. We need a general tolerance for us, and let's say I'm gonna write this way. Wait, I'm gonna find it. Notes. Can't find the tolerances. Yeah. No. Okay, we'll write it plus minus sign. We'll get plus minus sign. The plus minus 14. Let's look at it. Plus minus it 14 divided by 2. Yeah. So plus minus it 14 14 by 2 tolerance. If you want to know what ET 14 by 2 means, you can have a look. ET tolerances. So international tolerances. So let's say ET for IT14, it's here. And let's say you have like 10 millimeter to 10. So your sheet is, let's say 3 to 6, yeah. So your tolerance is 0.25 millimeters. So you can make like 0.12 millimeter mistake to left or right, so it's okay. That's the limit. You shouldn't go further from it. So that's the tolerance. The smaller the tolerance, the more accurate it has to be. It's micrometers. The higher the tolerance, the more inaccuracies are allowed. IT18 allows 1 millimeter imperfections for this. So that's about tolerances. Now we go back And we have to write to this production guys that uh, after after welding the bended part, perform do perform calibrative calibrative bending procedure. You have to write it. If you don't write it, tomorrow, if the product becomes very bad shaped and they blame the designer instead of taking the responsibility, so you have to write it and to get yourself away from problems. Then you right click on this, get to edit sheet format. Here you write the name of the drawer, the checker, approver, manufacturing guy, quality assurance guy, signatures, dates, material. So material will be, it's style 3. And there are also other parts to fill. I'm not gonna fill it, but if you want to make it auto filled, you can do the following. You can save sheet format. So you save it as Khazar's sheet, and when you just create a new drawing and you just cancel it, you go to the sheet properties and you pick the property you need, and let's look custom size. Where is it? Cancel sheet, edit sheet format, properties. I can't browse. Yeah, browser at there, Khazar. That's it, I think. So automatically it gives you this ST3 I wrote in the previous one, so it saves the sheet data forever. That's it. But only one thing I forgot, it's the surface finish, and we will put, yeah, we will put 2.5, no, we will put 12.5 for surface finish. 12.5 means plasma cutting, like, yeah, and this one should be like this. And we will also put a surface finish of no operation on this part as well. So no need to machine the surfaces of the sheet plate. Let me give it some angle, 250, 220, yeah. So machine operator, when looking at this drawing, he will understand that the sheet surface doesn't have to be machined, only the edges have to be machined and these bevels. So we also have to show this bevel here. I forgot. Yes, we do this. We put it here. We make it scaling 1 to 2. User defined. 2 to 1. And yes. So detail D. We put D a little bit far. And we give the dimensions, which well, I need angle. I think I'll just draw a line inside it to make an angle. That's pretty much it. So let's do it. 25 degrees without the comma. I'm gonna give the yeah 4 to 25. That's it. That's how you do it. I think that's the end of it. Yeah, that's pretty much it. It's full. Yeah, the names has to be there, the title, but I'm not gonna do it. Not in this class. That's it. I'm saving it. And from you, I expect you to do all this by yourself. So we save it here. That's pretty much